Okay. So now we're ready for section 4.2. And we're going to find the value of all 6 trig functions. So this will be good to help you with your memorization. So I have a random triangle. This is not one of your special ones. This is a random triangle, right triangle. And you are going to find this value of the sine, the cosine, the tangent, and then the reciprocal functions, the cosecant, the secant, and the cotangent. Well, we've already sort of practiced this. If you have a question like this on your quiz, only it's only one function, not all 6. So pay attention. I'm going to write down SOHCAHTOA at the top. And I'm going to write down the reciprocals underneath. And then I'm going to pay attention to where that theta is. This is the hypotenuse. What's the 2? Opposite. And the 3 then has to be adjacent. So now, filling in sine, cosine, and tangent should be pretty easy. SOHCAHTOA. So what will the sine be? 2 over root 13, which, remember how we rationalize that? How do you get rid of the radical on the bottom? You don't square it. Oh, no, we don't square it. We multiply the top and bottom by root 13. So we end up with 2 root 13 over 13.
Yep.
That's what we have to do if we have a radical in the bottom. What's the cosine? 3 over root 13. So I'll do the same thing.
Root 13 over 13.
And get 3 root 13 over 13. What's the tangent?
2 over 3.
2 over 3. So is everybody okay with the first 3 answers? Now those 3 are even easier because they are just the reciprocals, right? Let me give you a little hint though. Don't reciprocal this, reciprocal this. Because if you flip this over, where will the radical be? On top. If you flip this over, where will the radical be? Bad news. So let's flip this version so the radical is on the top. So the cosecant will be root 13 over 2. The secant will be root 13 over 3. And the cotangent will be 3/2. Does not get too much easier than that. Let's try another one. Now, where theta is extremely important because where theta is determines where opposite and adjacent are. So here we go. This is the hypotenuse. What's 12? Adjacent. And 5 is opposite. All right, so see if you can fill in the first 3. Fill in sine, cosine, and tangent. Hey, stop it. Fill in the first 3. Shiloh, Q's really trying hard. Don't mess him up. When you're done, look up here and see if you match me. Sam, we match? Everybody okay? Well, this one doesn't even have any radicals, so everything's easy. You just flip them over. So the cosecant and the secant and the cotangent. Hopefully when you walked into the room today, you got hit in the head by the Math League sign. Remember, tomorrow is opening day.
Can you explain What do we get if we go? Like, what is this class?
You're just coming to have so much fun. Just quit it, Logan. You're just coming because it's fun.
Is it like if you do well? Like, is it based on how you do on it? Like, how
No,
you get it right?
based on your effort.
This is four.
What?
Will there be a grew dogs? Grew dogs.
Oh, they're not hot dog sausage. It's breakfast. So
Okay.
Miss Dr. Greer will be here grilling sausages. Yep. Tailgate starts at 6:45. Contest starts promptly at 7:15. And if you've participated before, you know the minute the clock hits 7:15, the doors shut. So if you're running down the hall on your way, too bad, so sad, you got to be in your seat at 7:15. Cafeteria, any math classroom, or any basement room. Okay, plenty of spots. You just got to get there. Traffic is terrible on opening day. It will be backed up down the hill with parents dropping off the little freshmen and sophomores. So you need to accommodate that. You need to be here. Be here early. Miss Ford will be here. Be here. All right, here we go. Oh my goodness, what's different about this problem?
There's a different spot, and there's a missing part.
There's a missing side.
A squared plus b squared.
We're going to have to do the Pythagorean Theorem. It's a right triangle. So we're going to do the Pythagorean Theorem to find the missing side. So here we go. 1 squared plus 3 squared equals x squared. Right? So what do I end up with? 1 plus 9.
Oh no.
X is going to be the square root of 10.
Rolled square root, my bad.
And that's the hypotenuse. So look where theta is. What's this?
Opposite.
The 1 is the adjacent side, Sam. Look where theta is. Next to.
I was looking at the squares and I don't know why.
Oh, Sam. All right, so here we go. We're going to have a radical again, so pay attention to that. So we have 3 over root 10, which when I multiply top and bottom by root 10 will give me 3 root 10 over 10. Same thing's going to happen with cosine, only it's going to be 1 over root 10, or root 10 over 10. And then tangent is opposite over adjacent, which will be 3 over 1, or just plain 3. Now we'll do our reciprocals. Remember, flip the one that puts the radical on top. So you're going to have root 10 over 3, root 10 over 1, which is just root 10, and then 1/3. You all right with that? Now the next one is kind of the same, but I want you to be really, really careful with your Pythagorean theorem. Anytime you have one side missing, you're going to have to do the Pythagorean theorem, but it's a little bit different this time because the side that's missing is not the hypotenuse.
Put it in for A.
So the Pythagorean theorem is going to say 2 squared plus x squared equals 5 squared. Because when you do the Pythagorean theorem, it's always side squared plus side squared equals hypotenuse squared. This one is always the hypotenuse. The one that's over here by itself is always the hypotenuse. And that might not be x, right? In this problem, it's not x. So 4 plus x squared equals 25. So x squared equals 21. And x will be the square root of 21. All right, so Gabby, I know 5 is the hypotenuse. what is 2? Here's theta, so what's 2? Adjacent, and that makes this opposite. Everybody still with us? All right, fill them in. Fill them in, let's see what you get. Fill them all in, all 6 of them. When you're done, look up here and see if we match. Are we doing okay?
Yes.
Pat? You alright? You dozing off there? Any question about this? Did you remember to rationalize over here? Make sure that radical is in the top, not the bottom text.
When you were writing out the names, do you have to put the theta?
You do.
You
You do. Yes, you do. SIN means nothing by itself if you don't attach an angle. So yeah, get in the habit of putting, now, if you don't like thetas, sometimes that bothers us because that's a new symbol for us. You're free to make it X or
do? Okay.
M or, you know, some other letter. I'll use theta if that's what's in the problem, but you can always change that variable because that's all it is, it's a variable. All right, ready? Now we're gonna do something very, very similar. So I'm not gonna erase everything, I'm only gonna erase this stuff because we're gonna be doing exactly the same type of situation. Only this time, the picture is set up for us, but there's no numbers in it. None, no numbers. All we know is that the sign is 2/3. New piece of information. Whenever we're drawing our own triangles, we're gonna put them on an axis system like this. All right, so this is how I want you to get used to drawing your angles. And theta will always be the angle at the origin. Theta will always be the angle at the origin. Okay. So what do I know? I know that the sine is 2/3. Can I put those numbers into my picture?
Yes.
Where would I put the 2? The opposite side, which would be here. And where would I put the 3? The hypotenuse, which would be here. Now, I'm not trying to confuse you, but I'm hoping this helps you. If you envision a big circle, you don't have to draw it, just envision a big circle around there. Wouldn't this be the radius? And this, if I look at my triangle, this is X and this is Y. So sine is Y over R. Isn't that what it is? Sine is the Y coordinate over the radius. That's your other definition. All right, well, you don't need any of that. What we need is to fill in all the rest of the functions. Well, if the sine is 2/3, I automatically know the cosecant is going to be 3/2, right? Anybody that misses that, deep trouble. But what about the rest of them? What am I going to have to do in order to find the rest of them? I'm going to need the Pythagorean Theorem. Marco, am I keeping you awake?
Yeah.
Okay, I'm going to do the Pythagorean Theorem. Be careful. X squared plus 2 squared equals 3 squared. Make sure you're setting it up that way, because the hypotenuse is the one that has to be over here by itself, right? So here we go. X squared plus 4 equals 9. So x squared equals 5, and x equals the square root of 5. Now can I fill in the rest of them? Yeah, that's just like the other ones we did. So the cosine would be root 5 over 3, which, oh, by the way, is x over r. Cosine, x over r. Tangent is 2 over root 5, or 2 root 5 over 5. That is y over x. This is an axis system. That's your x, that's your y. Secant, 3 over root 5, or 3 root 5 over 5. And cotangent, root 5 over 2. That problem started off looking a lot different than the other ones we did, but ultimately it's the same thing.
So, Miss Ward,
What?
if there was no answer given to us, what would we do?
Well, you have to have something to do.
So you wouldn't take the angles for the compass?
No.
Oh, okay.
No. You only take the angles from the compass in a navigational problem. If we were any other kind of trigonometry, they have a different way of referencing them, which we haven't talked about yet. Ashley, you wait. Pay attention, sweetie. Okay, I need your focus. Okay. Here we go. Next. Oh, shoot, I'm on the next page already. All right. So what do I know this time? Well, here's my picture. Again, same picture. And this time, the only thing I know is that the cotangent is 1/4. That's given, which automatically means the tangent is 4 over 1. Right? So where do I go from here? How do I go about filling in the rest of the stuff?
Find the
Go up
tangent.
to my picture. I'm going to always remember theta is here. Mrs. Ford's not putting theta in the picture. You need to know it's at the origin. Okay? It's at the origin. Now, tangent is 4
So you're gonna
over 1.
one at the bottom.
So 1 here and 4 here. Does that work out okay with everybody? Opposite over adjacent, 4 over 1. Now I need my hypotenuse.
Isn't it a plus a squared plus b squared?
1 squared plus 4 squared equals the hypotenuse squared, right?
And that's 17. Wouldn't that be 17 squared?
So 1 plus 16 is x squared, so 17 is
Square
x
root.
squared. Square root of 17?
Yep.
Now, I know most of you know this, but I really want you to be conscious of this. Does everybody understand why when I did this Pythagorean theorem, the x was here, but when I did that one, it was over here? What? That's right. This is the hypotenuse. The hypotenuse is the one that is equal. Equal hypotenuse squared. All right, sine. Here we go. Sine would be 4 over root 17, or 4 root 17 over 17, right? Cosine would be 1 over root 17. Now, we've done enough. I'm not labeling opposite and adjacent hypotenuse anymore, but if you need to or want to, do it. This is adjacent, this is opposite, this is hypotenuse. Across from the angle is the opposite. In that setup, y will always be opposite. X will always be adjacent in that setup. Okay, you with me? All right, let's do our reciprocals. Remember, flip it so the radical's on top. So we're going to flip this one. So cosecant is going to be root 17 over 4. And cosine will be root 17 over 1, or just root 17. I know it's the last period of the day. This is important stuff. Stay focused. All right, 2 more, and then we'll do something different. Oh my gosh, in C, I didn't even draw the picture for you. So you're gonna have to draw your own picture. So there's your axis system, and there's your triangle, and there's your theta. That's what you're gonna draw to help you do problem C. And we know the cosine is root 5 over 3. Most of your triangles are going to involve radicals, so you just need to get used to it. Okay, here we go. Cosine. Where do I put the root 5?
Bottom.
Bottom. Where do I put the 3?
Above it.
Above it. And then I'm going to step over here, and before I forget, I want to make sure I get guaranteed points. If that's the cosine, then this will be the secant, right? Guaranteed. Can't miss that. I have a side missing though, so I'm going to have to do my Pythagorean Theorem, right? So here we go. Root 5 squared plus x squared equals 3 squared. What is root 5 squared?
Root 5?
Just 5, that's exactly right. When you square a radical, they cancel each other out. So it's just 5. Plus x squared equals 9. So x squared equals 4. And x is going to equal 2. What's the sign? 2 over 3, which means the cosecant is 3 over 2. What's the tangent? 2 over root 5, which means the cotangent is root 5 over 2. And I'll simplify this, or rationalize it, I should say, rationalize it. Bless you. All right, you're all bored out of your mind. You're gonna listen to me drone on. So try that last one on your own. See how far you can get with that last one. Start by drawing your picture. Make sure you're framing it like that. This looks awfully familiar. I think we've already done this numbers. The one right above it?
One before the one above it.
Don't just blindly copy mine down. Make sure you can get, did you do your Pythagorean Theorem and get 1?
Yes.
Okay, you put it down here because you were given the cosecant, so you had opposite and hypotenuse already, so that's the adjacent side. Is there anything there that's worrisome to you? Nope. We're good? We're watching the clock.
It's looking at me.
All right, ready? Because now we're going to do something sort of related, but quite different. Sine pi over 6. Without a calculator, you are going to come up with the value of the sine of pi over 6.
Oh.
All right. What did you say? Pi is 180, so pi over 6 would be what? 30. So Jalen is all over this. He says, all right, Mrs. Ford, I don't do this radian thing. It's too confusing for me. So I'm going to change that pi over 6 into degrees. And since I know that pi is 180, this is something that we must have memorized. Pi is 180, right? Then I'm going to do 180 divided by 6, and that is 30. So I am being asked to find the sine of 30. Now, in the problems we just finished, we were asked to find the sine of theta, and all the other things too, but one of them was the sine of theta. So I want you to draw that picture exactly, only instead of a theta, you're going to put a 30. And where does it go? At the origin, because that's where we mark them. Our angles are marked at the origin. So when it was sine theta, we put theta right here. Well, this is not sine theta, this isn't sine theta, it's sine 30. Okay? Well, wait a minute. If that's a right triangle, isn't this a 30, 60, 90 then? Well, wait a minute. If it's a 30, 60, 90, I know this is 1, this is root 3, and this is 2. How do I know that? Because I'm memorizing it. Oh, yeah, gold sheet. Now I want the sine. Well, wait a minute. The sine is opposite over hypotenuse, right? So in this setup, here's the angle. This is the opposite.
1 over 2.
And this is the hypotenuse. So the answer to the question is 1/2. That's it. That is huge. That is a huge skill, a very important skill. Very nicely done. Let's try the next one. We're going to find the tangent of pi over 4. All right, so the first thing we might want to do is figure out, okay, what angle are we dealing with here? Pi over 4. Well, pi is 180. Divided by 4 would be 45. So this is the tangent of 45. So now I'm going to set up my picture like I do. And I'm going to put the 45 right here. You know which one this is. This is a 45, 45, 90 triangle. Which means the sides are 1, 1, root 2.
You know how I do that? I've been studying my bullshit.
I love you, Tex. I don't know how you studied it when it was in my room, but I'm glad you somehow managed to do it.
That's that one night.
Tangent. What's the
1 over
definition of
root 2.
tangent? Opposite over adjacent, so that, here's your angle, so that's gonna be 1 over 1. The tangent of 45 is 1. Just a few more, here we go. Secant pi over 3. What's pi over 3? 60? How do we know it's 60? Because we know pi is 180. Pi radians are 180 degrees. So we've got 180 divided by 3. We're finding the secant of 60. So we're going to draw our triangle exactly the way we always draw it. We're going to put 60 right there. This one up here would be 30. Do keep in mind, this is the angle we're looking at, though. That's important, because you got to remember, this is opposite, right? Okay, so 40, 60, 90, the sides are 1, root 3, 2. Does it matter where you put those? Yeah. The 1 has to be across from the 30, the 2 has to be across from the 90. Now I want secant. Secant is reciprocal of cosine. So cosine is adjacent over hypotenuse. So I need hypotenuse over adjacent. So hypotenuse over adjacent will be 2. 2 over 1. When you do these problems, guys, x is always going to be adjacent, y is always going to be opposite. X is adjacent, y is opposite. Cotangent, pi over 6. Step 1, let's see, PJ, step 1. So that will be 30, cotangent 30. Izzy, step 2.
Draw your picture.
And when I draw my picture, I always use this setup. And right here is where the 30 is going to go, right? That's important. The angle you're doing in the problem goes at the origin. So here's my 60 up here. This is the angle I'm looking at, though. So 1, root 3, 2. Cotangent. TOA. Tangent is opposite over adjacent. So this is going to be adjacent over opposite. Cotangent reciprocal. What's the adjacent side? Adjacent, root 3, opposite is 1. Let me say it again, adjacent is always x. When you have this setup right here, when you're on the origin, on the coordinate axis system, adjacent is x. Opposite is y. Okay, I think we got 2 more. Let's get them done. This is great practice for your quiz. Here we go, pi over 4. What angle is that? Pi over 4 is 45. One root 2. What's cosecant?
It's
Reciprocal of sine.
Love it. Reciprocal of sine. Sine is opposite over hypotenuse, so we need hypotenuse over opposite. So root 2 over 1, which big kids will write as root 2. What's what's pi over 3? I'm doing the last problem. You're doing it with me. 60. That's how it was. She's yelling about something. So what's the cosine? Adjacent over hypotenuse. So in this picture, that would be 1 over 2. Bingo. Perfectly done. All right, let's hang on for the prayer. When I see you next, we will have our
Thursday.
memorization quiz.